Welcome to this video on an introduction to macro writing in ImageJ and Fiji. I'm Stephen Cross and I'm from the Wolfson Bioimaging Facility at the University of Bristol. This course is split down into two parts. In this first video we're going to be covering the basics of ImageJ macros, so what they are, when we'd use them and why we'd use them. And we're going to do this in the sort of view of fundamentals of programming, so basic programming concepts such as variables, loops, conditional statements, with relation to ImageJ macros. As such, don't worry if you've got absolutely no experience with programming in any language, we will be assuming no prior knowledge. We do, however, assume a bit of prior knowledge and familiarity with ImageJ, so if you haven't already done so, please go and check out our video on the basics of ImageJ in Fiji. You can find a link to that in the description below. So as we work through this video, you will find some worked examples. These are included and can be downloaded from a GitHub page that we'll look at on the next slide. And you know when we're coming up to those because you'll see this in the bottom left-hand corner of the slide. And these examples will work through things like using loops, conditional statements and functions, and so on. The second part of this course, Dom will be taking you through a worksheet which allows you to apply these processes and principles that you've seen in this video into creating your own macros. So starting relatively straightforward, loading images, using the macro recorder to identify functions, then going through generating graphical user interfaces or basic dialog boxes so that if you were to give your macro to someone else, they'd be able to use it and control it without having to edit any of the fundamental code. And then finally ending up at creating a single working macro that allows you to load images, apply settings to a GUI, detect objects, and then run a bespoke analysis on them. All the course materials are available from our GitHub repository. There's a link just shown on the screen at the moment, and again, there's that link in the description below, so you can so you don't have to type that into your browser. You'll see a whole load of different folders here, not all of which you actually need for the to run the course. Some of these are just images for the GitHub repository. The folders of interest, we've got this example data folder. You'll use that when working through the next video with Dom. So these are the images used for the worksheet, like when you're loading in images and also doing some of the later object detection steps. We've also got this lecture macros folder. So these are the example macros that I've just spoken about. You can load these and download these, download and load these right now if you want, and then just we'll go through them as we come to them. Then we've also got a separate macro folder, so this worksheet macro folder. So these ones you can download now, but would advise not looking at until you've at least had a go with the relevant exercise yourself. We've provided these as sort of model solutions, and also if you just get a bit stuck, you can refer to these and see maybe what it is that you should be doing. We've also provided these PowerPoint slides, as well as a Microsoft Word document containing the worksheet and exercises. Rather than downloading individual files and folders, if you go to the GitHub and click that big green code button, then you can download all of this in a single zipped folder, which you can extract on your computer and run from wherever you need. At this point, it's also really useful to have an idea of where you can get help. Now, obviously, you can drop us comments in the video comment section if you've got questions, or you can put in you can message us through GitHub. You could use, for example, the issues on GitHub. But probably the best place to start is by going to ImageJ's own documentation, because it's just fantastic. There's both the imagej.net, sort of the newer documentation, as well as the imagej.nih.gov website, where you'll find the original documentation that introduces macros and how to write them. In addition to this, the third link here gives you a complete list of all the baked-in macro functionality that ImageJ understands. So, what exactly are macros? Well, effectively, a macro is just a sequence of commands that's going to automate a series of processing steps in ImageJ. So these commands, every time you click something in ImageJ, this command is being sent to the processor. Now that might be a command such as load a particular file from a particular location, It might be apply a median filter with a particular set of settings like radius and so on. Or it might be to run a plugin from ImageJ with a particular set of parameters. The reason that you would want to use a macro is simply that even if you know exactly what you're going to do, like you've got a very well-defined workflow, it's still going to take you a while to click through, like load your image, apply this filter, apply a threshold, run the analyzed particles. And maybe that takes you 5 seconds and you think that's okay. But that's okay until you've got 20,000 images from some high content system, at which point you would really like to be able to say, well, these are the steps I want to use, and can you just apply that to all 20,000 of these images in a particular folder? And that's where you would use a macro. So not only does it prevent you having to apply those steps manually by clicking, it's also going to do it a fair bit faster. Maybe it took you 5 seconds, the macro is probably going to do it in a fraction of a second. You can also use it to extend functionality of ImageJ. Like say, the third link on the previous slide, there are hundreds of different operations that a macro can do. However, chances are there's going to be things that you want to do that the macro can't do. One example of this is later on we're going to be looking at detecting different objects and then measuring their nearest neighbour distances. That's quite a custom analysis to want to do, involving reading different columns from a results table and making particular measurements and then outputting them in a particular format. And it can't be expected that ImageJ is going to have all of those different capabilities pre-programmed as macros. Indeed, what you have to do is then you would just use a sequence of commands and the basics of programming that we're going to go through to automate this so that you could, in addition to your macro where it's loading and filtering and identifying objects, it then automatically goes through and does that analysis for you. You can kind of imagine the structure of a macro like this flow diagram on the right hand side. So on the right we're going to build it up, so we've got our start and stop nodes there. And we can kind of think of operations in this macro of falling into different categories. So the first one here would be an input operation. And here we're going to assume we've already got our image loaded, and we're going to set a threshold intensity for determining what pixels are foreground and what pixels are background. Now maybe this is explicitly setting the threshold, like it's hard-coded into the macro code, or maybe there's a dialog box that pops up, or maybe it's determining it through some calculation of intensity, like using an automated threshold. Either way, this is effectively an input, like you're putting information into the macro as to where that threshold should be. Next, we're going to have processing operations. So in the context of our workflow here, we've now binarized our image using the apply thresholds and then detect objects or analyze particles, as it's called in ImageJ. So those would be examples of processing operations. We also have conditional statements. So this would be, for example, here we are looking at another input. So this is now measuring what is the number of objects that have been detected in that previous processing step and assigning it to a value n. And now this conditional statement says, well, is n greater than 0? Because if n isn't greater than 0, we haven't detected anything, and there's no point doing anything else. So we just skip straight to the end, to this stop. However, if that conditional statement comes back true, yes, our n is greater than 0, we've detected something, then we can progress on to the next block. And this next block, all of this here, could be considered as a loop. So in this case, this is a while loop. So we set our value of I equal to 0. So I here is a variable. It's just going to store this number. It allows us to access the particular iteration in this case. So think of that standing for I. We will go through this in more detail, but basically what we're doing is we're starting off by saying is I, which is currently set to 0, less than n, and let's say n is 5, like we've detected 5 objects. So yes, I is less than n, so we continue. We would do some custom processing step here, again, with the square green box. We'll look at these like custom functions later on as well. And then we do another processing step here, which just increments that value of I by 1. So I was previously 0. Well, we're going to redefine that value of I as its previous value plus 1. So now I is equal to 1. Now we come back here in our loop, and go, is I, which is now 1, less than n, which we said was 5? Yeah, 1 is still less than 5. So we've got more particles that we need to analyse. So again, it goes back through, measures its distance, increments the value by 1, so I is now 2, 2 is still less than 5, and we keep going until the point where we get to I is equal to 5. And so 5 is not less than 5, so now we go no, and then we come to our last class, which is output operations. And in this case, maybe it's just showing the results table. And of course, the logical place to start here is right at the end. In fact, the sort of classic way to look at any programming language for the first time is to generate what's called a hello world code. All this does is you just want to use the minimal amount of effort in your program, or your macro in this case, to display the words hello world in the output. The idea of doing this sort of in general with programming is it just gives you a bit of an idea of what's the minimum syntax required or minimum structure required in your code to make it run anything. Nice and easy for ImageJ macro is that it is literally just the function print, then in brackets this argument here, hello world. So this is a string, a piece of text, and we will look at all of these different components later on, like function formats, strings and numeric values. But right now we just put that in and it should display the words hello world. Similarly, we could do this with numbers. It doesn't need to be text. So if we put in print 42, it would display 42. So we now come to our first example macro. So what we're going to do is we're going to go to that. I'll talk through the macro structure and we'll just check that this works as expected. Okay, so for this first macro, what we're going to do is start right from scratch. So I'll launch Fiji here, and then you can see that I've already downloaded and extracted all 8 of the macros that we're going to be using today. If you've got an existing macro, you can just drag and drop it into ImageJ and it'll open up in the script editor. But for the purpose of this first macro, I'll show you how to open a blank window. So if you go to File, New, and Script, you'll get the script editor here. And in this you can go File, Open, and then I'll load in that first macro there. This can take a couple of seconds as it just initializes. But what you'll see when we've done this is that there's a specific format to all of these macros. Let me just resize that slightly and make the text a bit bigger. Somewhere here, there we go. Let's try that. That's a bit better. So now we can hopefully see that. Okay, so the way I've laid out these macros is that you've got a bit of description at the top. So the first thing here just tells us what the objective of this particular macro file is. In this case, what we want to do is to simply display a message in the log window, and that is the whole purpose of the hello world program. After that, there might be a bit of an example as to a real world situation in which you would want to do this. So for example here we're saying we've automatically calculated the intensity of a threshold for an image and we want to see what value is actually being used. We don't want it to be a black box, we want to know what threshold is being applied. Then you can see any number of notes. So here I'm noting that anything with a // so // at the beginning of the line is actually a comment. So anything like this you can see is automatically coloured green, and these lines are just ignored effectively by ImageJ. When it's interpreting this macro, it just skips over those, knowing that those are just simply messages between the person who's written them and anyone reading them. Also here, and in fact we'll touch again on this in the next slide, is that semicolons need to be included at the end of pretty much every line, or at least every command. There are a couple of exceptions and we'll cover those as and when we get to them. And then the last thing you'll see is the code section with the different bits of code in it, again with comments throughout sort of explaining what each line is doing. So here, simply we're using the function print and then passing in the value hello world. So this is just telling ImageJ to print a message in the log window saying hello world. It'll automatically then also print the number 42 and print a blank line. So if we click run now, that's exactly what we get. In fact, again, I'll make this text a wee bit larger. So there we go, hello world, exclamation mark, and 42. So that's nice, that appears to be working. Okay, so as I briefly mentioned in the macro we just looked at, semicolons are an important part of, well, not just ImageJ macro writing, but also a lot of other programming languages such as Java. The semicolon effectively just tells the interpreter or the program that where one command ends and the next one starts. The other thing that's really important to note is this idea of sort of the foreground background logic within ImageJ. So ImageJ has a kind of global variable that allows it to consider what is foreground and background. And so that can either be set to be that it's a black background with white objects, or vice versa, you've got a white background with black objects. By default, I believe ImageJ is set to have black objects on a white background, but the sort of danger territory is that if you've set up your macros and everything works such that it's assuming black objects, white background, and then you give it to someone else or you run it on a different computer that's set to the inverted logic, then your macro might behave differently. So the first thing that you should really do in a macro is to use this command down here, this set option black background false. What that will do is it will standardize ImageJ from that point onwards that it's going to be black background, white objects off, so effectively black objects, white background, and should just allow better compatibility between versions. So the first of the fundamental programming concepts we're going to look at are variables. And variable is just effectively, it's a reference to a piece of information in the memory. So rather than, for example, if you had a macro where you wanted to refer to the same, maybe radius measurement, maybe you've got a bunch of filters in there that you all want to use a radius of 2 pixels. Now you don't want to have to go through and maybe change that on 4 or 5 lines, changing that value of the radius, because then if you later on decide that you need a radius of 5, you'd have to go through, find all those instances and change them. Instead what you could do is you could assign a reference value, this variable, you could even call it radius, set that equal to 2 or 5, and then just leave that at the top of your macro, one of the first things that maybe you assign in that macro. And then subsequently in the text, in the macro, all you would do is you would just need to refer to that value, that name, radius. So instead of writing 2, you would literally just write radius. And ImageJ would then be able to insert that in, and it means that you only need to change these values once. It could also be useful for accessing images. So a lot of the functions within ImageJ expect explicit image names or window names, such as if you're concatenating 2 images together, it will say, you know, take this window and take this window, combine them, create the new window. However, you want this to be as sort of flexible as possible. So if you then load a different image, it's going to have a different window name, but you can't have your code hard or your macro hard coded to a specific name. You don't want to then have to go through manually change the names in those relevant functions. That would probably take longer than just clicking through. So instead you could use something that maybe got the image name and then assigned that to a variable. In fact, there's the getTitle function, which we'll look at later on. And so you could assign the current image or the current window name to a variable, and then you just use that variable reference going through in your code. So there's kind of 3 main classes of things that can be stored in variables. You've got numbers, like literally just integers or decimals. You can have strings, so these are sequences of text characters. And an example I've given there would be like the name of a smoothing filter. And then also arrays. So this is effectively a 1D list of numbers or strings, and it's kind of equivalent to a column in a spreadsheet. And an example that I've given there is a list of open image names. It could also be, for example, a list of filters. So later on, when we're looking at dialog options with DOM, there's one where you can create this drop-down menu, and that menu needs to know what options it can have. And you tell that particular dialog box what its options are. You pass those in as an array of text values. So you say, well, you could be Gaussian blur, median, mean, max, and so on. Right, looking at working with number type variables. So as I sort of alluded to previously, you can have this reference, so it's largely up to you what you want to call that reference. In this case, I've just called this number reference that I'm creating num_var, and then you assign that equal to this fixed value. Now, it doesn't have to be a fixed value, as I mentioned previously. It could be something that's sort of being dynamically calculated, such as the image name or the window name, and we'll look at how that works later on. But for now, I'm just assigning this variable numVar to the fixed value of 42. There are a few conventions as to what our variables can be called. We can't start with an actual numeric character. It has to be a sort of a text character. There can't be any white space in it, so it couldn't be num space var. That's why we're using this underscore. And I guess that's about it. Oh, well, you can't have any funny characters. You couldn't have like percentage signs, things like that in there. So basically just alphanumeric, no white space. That's the easiest way to remember it. Once we've got our numeric variables, we can just do standard mathematical operations on them. Got a quick one down here. So in this example, I've created another couple of variables. Again, the name here really is up to me, so I just called it my_var_1, but you could call it whatever you wanted as long as it stuck to those few simple rules. And I'm assigning that a value of 10. I've also got a second variable here, which I'm assigning to a value of 5. And then in this one, I'm generating a third variable, and I'm going to do some mathematical operation to calculate this third variable based on the two values that I've hard-coded. So in this case, it's myvar1 plus myvar2, both of those added together, then multiplied by 7. And a few concepts here. You can see that all I'm doing here is effectively just replacing where I would have previously maybe hard-coded 10 and 5. I'm just using these references, and you can mix this in with hard-coded values. You don't have to just have variable names. You can still use explicitly defined values. And then we should find that myvar3 has a value of 105. And indeed, we will have a look at our second example macro now and hopefully see that that is indeed the case. I've already opened up this macro, used exactly the same method as before, so just going to File and then Open and loading in the file. So as before, we've got objective here. So the idea here is just working with number type variables and to get an idea of how they work. Here we go, as mentioned in the main slides, talking about storing parameters at the beginning of a macro, and then just some key notes here about how we should be using variable names. And then basically we've got the same sort of logic as the slides previously. So here I've called my variable numVar, assigned it 42. I'm then going to use that print statement. So just how we saw with the hello world, now I'm just going to be typing the number stored in numVar, and then I'm going to print out that value. And then I'm going to do that calculation with 10 and 5. Again, calculate that and then go the number from the calculation, and then that should print 105. So I can just click run, and on the right hand side we see that that has indeed worked. So it prints out the number stored in numVar, colon, and then on the next line, rather than typing numVar, it has just used that value 42. So the thing that we'll really see in the next slide is that explicit string or explicit text that we want it to display uses these quotation marks here, whereas when we don't use it, you'll see that it's coloured black and it applies to a variable. So as with comments, which come in green, functions, which are this delightful sort of browny, yellowy colour, we've got text here in pink, we've got numbers in purple, variables in black, and there's also little bits of red for kind of like structural elements, and then you'll also see a few keywords later on highlighted in blue. And that, you know, it looks fine, it's pretty enough, but the main benefit here is that as you're typing, you can straight away see whether what you're doing is working. Like if I'd mistyped this statement here, I know that that function should be coming up in that yellowy brown colour. So it's like if it comes up in black, it's an indication that ImageJ isn't recognising that as a function. And indeed, when I get rid of that wrong character, it goes back to that. Same with the strings here. If that, for example, didn't have the end quotation mark, it again goes a funny colour, indicating that it's not behaving correctly. But yeah, so that's all worked well, and we can move on to the next bit, which is actually looking at strings. So strings fundamentally, like the assignment of them, works in a similar way to how it does for numbers. We are defining a variable name here, like our reference, and then using the equal sign and specifying our hard-coded value with the semicolon at the end. As before, we can call this whatever we want within those parameters, so no numbers at the beginning, no white space, no funny characters. And here, the one difference, as I mentioned in the previous macro demonstration, is that we have these inverted comma quotation marks, and that indicates that anything between those is a block of text. And with a couple of exceptions, ImageJ will just take that as is. So here we're allowed to start it with numbers, we're allowed to have white space characters, we're allowed to have symbols. There are a couple of symbols which will make it behave differently. Backslash is one, but you can read more about that online. It's sort of beyond what we're really interested in for this sort of initial introductory look. You can even do sort of, well, not really, well, basic operations, should we say. This one here is concatenation. So if we're assigning two different variables here to different strings, so we'll just call it first string and second string, we can use the plus sign here, and effectively it's just bolting one after the other. And again, we're mixing, as we did with the numeric example, we're mixing variable-based values with hard-coded values here. So in this case, what we're going to do is we're going to put in first string, so assign a new variable, which is the concatenation or the combination of first string, a single white space character, and the second string that's assigned to myvar2. And all being well, myvar3 should then be assigned the value which is those two with the white space in between them. So it should just say first string, second string. And again, now we can go and have a look at that in practice in macro number 3 from the GitHub. With the string type macro, it's exactly the same format as before. I'm no longer going to go through all these comments at the top because you can read those in your own time. They're there just to make it a bit easier for you when you come back to all of this. But basically we've again got the text from the slide. So in this case we're just storing the value your string in the string var variable. Same as with the numeric example, it's going to print out a line, the text stored in string var, and then print out that value. And then we're going to have a go at this string concatenation, so combining these two with that space, and again it's going to print that out and then leave a blank space. So we click run there, and it's done what we would hope. So the text stored in the string var, that is your string, and the concatenated strings, first string, second string, with that space. So if we were to remove that, what you would see is that now it's just those two strings. It's immediately after that one and into that one. The final of our fundamental variable food groups is the array. So as I mentioned, an array is kind of a 1D table of results, or a column of results. This is slightly different. It's not just a case of whereas before defining our variable and then saying equals and then just specifying the results. To create a new array, we actually have to use a function. So in this case, it's the new array function. And this can take a couple of different forms based on whether or not you want to create an empty array. So effectively just allocate a blank table. So tell it that there's going to be, say, 6 different elements to it, or 6 different rows, but not actually tell you what those values are going to be. Or whether we want to create those values right from the get-go. Something like this, that might be if we were taking measurements, if we were going to be iterating over all of the objects and then wanting to put those results into that table. You don't know at the time when you're creating that array what the values are going to be, so that would be when you use this one. Whereas here, more like if you're doing something like a dialog box, mentioned previously, having to give an array of different filter names maybe. In that case, you know that the filter options are going to be Gaussian blur, median, min, max, and so on. So you could actually explicitly write those in, create that array one time, and then you don't need to modify it. So just looking at this first one here, the format, as before, in terms of the variable name, I've just called this an array underscore var. equals, and this is new array, and then in the brackets, but not the purple bit, you would enter the number of elements that you want in that. So as I said previously, you might put in 5, and that would give you a 5-element blank array. And by default, it just populates those with the value 0. You could also, like say, generate these populated arrays. So it's the same format, except rather than putting in one value there, you would put in numerous ones. In this case, I did 42, 2.9, 56.3, and 43.2. You can also put in strings there. So again, using the quotation marks and comma separating them, and you can put as many as you want. The important thing to know is that once you've generated these, doesn't matter which way you did it, you can still access and modify the arrays in the same way. It's just the way that they're initialized that varies. So doing it for a blank array, we're going to go with this example here. So now I'm calling my variable my array, new array, and 3. So it's going to be a 3-element array. And one important concept here, which is common across a lot of programming languages, but not all, annoyingly, is that numbering for indices, so the sort of the number of the element, starts at 0. So your first one is going to be number 0, your second one is going to be number 1, and your third one is going to be number 2. And in this case, we've generated this blank array, so that would just be 3 empty numeric fields. And then to access a particular value, you use these square brackets. So you go my underscore array, square brackets there, you tell it the index, so access, all this is saying is access that 0, that first element, and then we're going to assign that. So this now is just kind of like a variable, but we're accessing the variable name at a particular location and then popping in the value string to store. Same if we want to do the second element of that, we would put in another string, and then for the third one, which is index 2, we would put in final string. That would look something like this, a schematic representation. So you've got my underscore array equals this sort of 3-element table, string to store, another string, final string, and then I've popped the index on the right hand side there, 0, 1, and 2. Accessing the data in this array works in much the same way. So in this, the examples on this slide, what I've done is I've initialized that array with some predefined values. So here we've now got a 4-element array with those 4 different decimal numbers in them. And say I wanted to access this value 42.0. Again, I would just use the variable name, my underscore array, and then square brackets 0, and that would just return this value 42. And the value that comes out of this, so it gives me the value 42, that's effectively like saying this block of text here is, as far as ImageJ sees it, is just the value 42.0. And so we can then assign a new variable, num from array 1, as 42.0. So now once I've run this line, num from array 1 should have that value of the first value there. Similarly, if I wanted to access this third value, index 2, 56.3, I could put num from array 2 is equal to my array, square brackets 2, and that value there would then be assigned that value. We can have a play with this in demo macro number 4. In macro 4, we've kind of got a couple of different concepts running, so it's a bit more complex than last time. Obviously, you can go through this at your own pace. Just pause the video, have a play around. You can just sort of execute different sections of this by commenting bits out. The easiest way in sort of modern versions of ImageJ to do this is just to highlight a section and then press Control and / and that will actually just block comment out entire sections, and then Control and / again to uncomment them. So what we've got here is we're going to generate a couple of predefined arrays or pre-allocated arrays. The first one is using numeric values, so 42, 2.9, 46.3, and 43.2, and we're going to assign that 4-element array to the variable num array. We're then going to use this command here, which we haven't seen previously, but it's just another function. So this is a function call. In this particular instance, the ImageJ interpreter doesn't recognize it as a function, even though it is. So don't worry in this case that it hasn't gone sort of yellowy brown. I know I previously said that that should be cause for concern. It's more just if it hasn't gone yellowy brown, it might not be right. Whereas if it's done that, you know it's right. So yeah, so this is still a function call, and then this is the value we're passing in. And all this line is going to do is it's going to pop up another little log window just showing us the elements of that array. and it will tell us the name of the array at the top. We're then going to do exactly the same thing for for a 3-element string array. So this one, very unimaginatively, is just going to be str1, str2, and str3, assigned to the variable string underscore array. And again, we're going to display that in another window, just so we can see that it's working as expected. The next part of this is going to be generating an empty array, like we saw on the slides. So this is just a 3-element empty array, so it'll be 0, 0, 0, and we're going to call that one my array. And then we're going to use this ability to assign values here using the square brackets notation and the indexing starting at 0 to assign these 3 strings there. So the first element is going to be called string to store. That's actually what's going to be stored in it. Then another string in the second one, and then final string in the third element. Again, I'm just going to display that so that we can see that we've got those 3 in there. And then as our last piece here, what we're going to do is we're going to use a combination of accessing elements from an array and string concatenation to create or assign a new variable which is concatenated string. And so this is my array, square brackets 0, so that'll be string to store, comma, another string, comma, final string. And this might all seem rather abstract, and really is abstract, and you might be wondering what this has got to do with image analysis. But it's really just getting you familiar with the fundamental concepts of dealing with different types of variables, different types of arrays, because these are going to be useful when we're actually doing image analysis based things in the second part of this, when you're working with Dom in the second video, going through those the worksheet and the macros that he's prepared. So let's give this a run now. So in that case, I just did Control R, which is a shortcut for run. And you can see that we've got our 3 windows here. So we've got num_array. We scroll up, and again, I'll change the font on that so you can see it a bit better on the video. So as expected, this is a 4-element array. So it's kind of like 4 rows, 42, 2.9, 56.3, and 43.2. And it just tells you at the top the name of that array. So this one's num_array. Same with string array. We've got str1, str2, and str3, the values that I inserted there. And finally, this my array, which is the one that I initialized blank and then put in those values. So these are the values that I specified: string to store in the first one, another string in the second, and then final string in the third. And then that last little bit was creating this concatenated string where it's the first element, second element, and third element, all comma separated. And that indeed is what has printed out to the log window. So we've got string to store, comma, that we've asked for here using this combination of variable-based and hard-coded string elements. Then the next bit, another string, comma, and then final string there. And then that was just printed to the log window. So now that we understand the various ways that we can store data actively within the macro, we can start looking at processing operations. So as my demo previously, or the flow diagram, we could consider these to be things like applying thresholds or detecting objects. Now, in much the same way that a variable allows you to store data in a way that you could call it back without having to write it down each time, a function stores an operation with just a short keyword. And we've seen these previously: the print statement, the new array statement, and then also that array.show function. So the general format of a function is shown here. We've got this returned value here, starting left to right. So if it's a function that will give you something back, like it's done a calculation and it wants to give you back a number or a string or an array, that would then come out here and you can assign it to this variable returned val. Then from left to right, you've got the function name. So this one again follows some rules, similar sort of rules to the variable names. So don't start with a number, don't have any funny characters in there like percentage signs or slashes, and don't have any white space. Slightly different here is the sort of general convention is that you use something called camel case, or in this case lower camel case, where you capitalize the first letter of each word, except for the first one, which you do in lowercase, hence the lower camel case. And then the final bit here, these are your arguments. So in the case of the print statement, we took a single argument. That would either be a string, so a piece of text, in the example of things like the hello world, or it could be a number, as we did do sort of print 42 right back in the beginning of macro 1. Different functions will have different number of arguments. So this example here, so function name, which obviously isn't a real function, I've sort of arbitrarily said, oh, maybe this one's got 3 arguments. They have to be specified in a particular order, as you will see later on. So say this one might be a, well, if this was a filter, you know, it might be an apply filter function, and then it would be the name of the filter and maybe the radius or something like that, or sigma for that filter. You couldn't spin that round. You couldn't have the radius there and the filter name there, because it wouldn't understand that. It's not able to pick up what you mean. It has to say, right, I'm expecting that first value there to be the name of the filter. But these are comma separated, and they can be different values. They could be numbers, strings, arrays, and so on. However, there are a few exceptions to this rule. One of these is that not all functions will return values or even take arguments. So a good example of both of these is the close function. So close is the function name. You still have to provide the brackets, although I think you don't necessarily need to, but it is definitely a good practice too. And it doesn't return a value. All this one does is it just closes whichever image is currently active in ImageJ. You also might find one or two which don't return values in the same way. So whereas most of these, like I say, you would use a kind of standard assignment format where you've got the variable name there equals and then the output from function name, things like the getDimensions function actually update these values that are given as arguments. So what you would do is you don't need to predefine these values of width, height, n channels, n slices, or n frames. When you run getDimensions, these values will be assigned. So you could then do print width and it would say 512, for example. So that's a bit different. I think this one and possibly the equivalent for getting details from a stack or a hyperstack work in the same way, but these are few and far between. Typically they're going to follow this function format here, and if in doubt you can refer back to the documentation online, that list of all the functions that are available. Going to look at a few example functions. So this getPixel function here just takes the XY coordinates in pixel coordinates of a pixel in your image, and it's going to return back the value or the intensity of that particular pixel. So this is a very standard format here. Return value, function name, and a couple of arguments separated by a comma. You could have one like the rename function. So this one accepts an argument. In this case, it's the name or the string that you want to rename the active image in ImageJ. So whatever image was currently active would then become called my image, and you would see that updated in the title bar of that image. There are also mathematical operations. So again, this follows a very standard function format where returned val equals the sine of 0.32, and in this case it's given back in radians. And that's the sort of thing that you would know if just by reading the documentation for that particular function. It's also important to know where to find this information. So, as I've just mentioned, you can go to this website here, and that gives you a full list of all the baked-in functionality for macros. You can also use the macro recorder. So in ImageJ, if you go to Plugins, Macros, and Record, it will open up this window here. And as soon as you start clicking around in ImageJ, every time, as I mentioned right at the beginning, every time you click a button, it's sending a command to the processor. It will display what command it is that it's using. So in this case, actually, it's run 3 commands, all of which the function is simply run, and then it's running this plugin for Z projection. So typically, this is the name. The first one here is the name, then comma, and then the second string argument here specifies all of the parameters. Like this is a standard format for running plugins in ImageJ. So here, projection equals max intensity. And the benefit of doing it this way is that it's just a very easy way to identify the exact format, especially when you've got a plugin which has got a lot of parameters and things that can change. This allows you to know that you're specifying them in the right order and with the right labels. The other one that's really useful is been included for about a year and a half now in the main Fiji build, and that's the auto completion here. So this is really cool. You can see here, as I'm starting to type, it's giving me suggestions for what it might be, what functions I might want to be using. So as I type G, I get all the different commands that start with G. So a lot of these are get, and indeed they don't change for the first 3 letters. But then as soon as I put in D, then it narrows down that list to all sort of 5 or 6 values, possible functions that start with get D. And you can see on the right hand side that for get dimensions, it also gives you a bit of a summary of that function. So you can see it tells you what it returns and what the different arguments are. So that's really nice when you're typing. So now we're able to use functions that have already been written for ImageJ, but what if we want to create our own? There's going to be a time where we're repeatedly applying the same bit of code multiple times throughout a macro. And we don't want to have to keep writing it, because if for nothing else, if we decide we're going to do it a slightly different way, we don't have to change it 3 or 4 times. Exactly in the same way that we would with like assigning a variable. You assign a variable, declare it at the top, and then you only need to change it once and it will propagate throughout the code wherever you've used that. All the same is true of functions. So we can create our own functions. These are specified within the same macro text file. And you can change the format, you can return value. Well, you can still only return a single value, but you can return a value, and you can take any number of arguments, much like you would with a standard function. The declaration for that function is this format here. So here we've got this blue keyword function that tells ImageJ that the next line corresponds to the function that we want it to evaluate. We give it a name, again following that camel case naming format, and we tell it our arguments. So in this case, I'm telling it that there's going to be arg1 and arg2. Now these are variables, so again we can call them anything we wanted. That could be arg_1 or my arg1 or anything. All that's important here is the order. So this is what I mentioned previously about the first one. When someone uses that function, you know what the first argument needs to be. It needs to be an image name, or it needs to be a filter radius, or so on. It's up to you. Then we have these curly braces. So you'll see these over the next few slides in the context of loops and conditional statements as well. But what these curly braces mean is that when you're running this function, to execute everything that's between these curly braces. And then when it's done that, that is the end of that function call. And then you also have this optional line here, which is to return a value. So here, at some point during this code to execute, I would have defined, in this case, a variable called val_to_return. And then if I want that to be the value that is passed back, I just need to use the return keyword here. And this should be the last thing that's in your macro in this block between the curly braces, because this effectively tells the macro as well to quit, or sorry, the function to quit. If, and as we saw, there are many cases where you wouldn't want it to output a value, you just don't need to include this line. When it gets to the bottom curly brace, it's just going to stop anyway. So an example of this, a very basic example, might be adding 2 numbers together. And this is a very basic example because obviously this only requires us using one operation, and so why would you go to all this effort to do num1 plus num2? Well, simply you wouldn't. But instead of just having this single line here, you might have 20 lines of code or 50 lines of code doing something much more complex. But for the sake of argument here, all we're going to do is we're using the function keyword. I'm going to call this function add numbers for obvious reasons. I'm going to say, well, we've got two arguments here. First one's going to be num1, second one's going to be num2. I'm then going to define a new variable here called result num, and then that is equal just to the sum of those, and then I'm going to return that value. Now, we could simplify this further straight away by just removing this value, this variable declaration here, assignment. It's just not necessary. We could just put return num1 plus num2 semicolon, but just for the sake here of showing that this is just a normal statement like what we've seen before. So assigning a value based off two input variables being added together, and then returning that value. So that's just a definition. It's not actually processed anything. It's just saying that now, if you type in add numbers, it knows what it should be doing. And indeed, that's the next line in our macro. I'm going to assign the return value here to the variable sum underscore number. And so that's equal to add numbers, our function name, and then the two arguments, which, as we know, should be numeric. So 3, 5. And then we'd just print that out, and hopefully it would display the number 8. For number 5, it is just as we showed before. So I've declared this function, add numbers, which is taking 2 numerical arguments, assigning this new variable result num, which is num1 plus num2, and then returning that. And then I'm going to use it a few different ways. So this sort of demonstrates the benefit of this. So we've created some number, which is equal to add numbers 3 and 5. And then I'm going to print this statement. So here I'm using a combination of string concatenation. So 3 plus 5 equals, and then adding in the number here. And I'm also going to then run this 3 more times with different inputs, 5 and minus 2, 0 and 0, and 2 and 10. And for each of those, I'm just writing this. That doesn't need to be there in terms of making it work. This is just so we have a nicely formatted output on the right-hand side. So if I run that, you can see that it's come to this one here. 3 plus 5 equals 8, which is good. 5 plus minus 2, when these were our inputs here, assigning to the value ex1, so example 1. 5 plus minus 2 is 3. 0 plus 0 is 2. 0 plus 0 is 0. 2 plus 10 is 12. So that appears to be working correctly, as we would expect for such a simple function. So far, we've been executing all of the functions one after the other, effectively whether we like it or not. And that's fine. If you're doing just simple automation, you're just reproducing a series of steps that you always do, like say load an image, apply a filter, apply a threshold, measure the number of objects, something like that. However, there's going to be cases where we're going to want a higher level of control. And some of that control comes in the format of conditional statements. So executing certain chunks of the code dependent on criteria. So saying, in the context of the flow diagram I showed near the beginning, if the number of objects n is equal to 0 or less than 0, which isn't going to be the case, skip right to the end because there's nothing to measure. And if it's greater than 0, so i.e. we've detected something, then progress through and do the measurement stages. So this one I've shown on the right hand side is a conditional statement, also referred to as an if statement. And the format of this shown here is kind of similar to that function declaration we looked at on the previous slide. The difference here is that we're using this if keyword, and then rather than having a function name, what we have is these brackets here, or these parentheses, and inside that we will be specifying a particular condition. So you'll see what we mean by that in the next slide. We're just sort of saying, is n greater than 0, for example. Then we have those same curly braces, and if this condition is met, then everything inside those curly braces, so between here and here, all of this code is going to be executed. If, however, this condition isn't met, it skips on to this one straight away and ignores this bit of code. So in this context here, the code that would go here would be all those measurement steps, measuring distances, nearest neighbor distances, and so on. We can have multiple different conditions which are effectively chained together. So these are your else if and else statements. So here we've got a sort of more thorough worked example. So we're going to assign this numeric variable a is equal to 1, and we're going to say if a is greater than 2, print a is greater than 2. Fine. However, if a isn't greater than 2, rather than just skipping straight to the end, we'll say, well, let's hold on, let's give it another shot, let's try something else. So say else if a is equal to 2, and then if that's the case, then it'll do this and say a is equal to 2. And failing all that, you can just use a standard else statement. And what this will do is this will execute if both of these have failed. It's also worth noting that you can have as many else if statements as you wanted. You could say if A is equal to 1, print something. If A is equal to 2, print something else. If A is equal to 3, print something else. But that's quite a crude way of doing it. But you know, depends on what you're trying to achieve. So if we look at this particular one, we know that A is equal to 1, so if this was going to execute, A is not equal to 2, so this fails, so it skips this bit, and now we're going to test the next bit. Well, else if A is equal to 2. No, A is not equal to 2, so again, this chunk of code here is skipped, and we go to the else. And there's no condition for this, it's just if we have an else statement, then it is going to print this. So this should say print A, which in this case will be 1, so it will say 1 is less than 2, which obviously we know. You don't have to have all of these components. You do have to have the if, but these are both optional. You could just say if this, otherwise, just have your else and just do something. Or you could just have a series of else ifs and else ifs and not have an else. It's up to you. Macro number 6. In this case, we're going to do things slightly differently. We're going to say we're going to assign a random number. So this will be a random number between 0 and 1. We're using the random function here. So this is a function which doesn't take any arguments, but does return a value, which we're assigning to the variable random number. We're then going to set a couple of thresholds. We're going to have a low threshold at 0.3 and a high threshold at 0.7. And then we're going to use an if, else if, and else statement to see whether first that random number is less than or equal to our low threshold, and if it is, print a line saying that, again using a kind of combination of string concatenations. Then we're going to try an else if that fails, so if it's above 0.3, and see if it's greater than the high threshold, and again we're going to say if that's the case, print this thing saying our random number, whatever that value is going to insert it in, is greater than or equal to our value, which is 0.7. And then we're going to, failing that, we'll try our else statement here. So just put that on that line, and then print that. So let's run that. And on the right hand side, you can see 0.1522 is less than or equal to 0.3. So that's good, makes sense. And I can keep running this, so 0.16. Eventually we'll get one that's greater. There we go. So 0.8575 is greater than or equal to 0.7. Now let's see if we can get one in between. Eventually, there we go. 0.4794 is between 0.3 and 0.7. So that appears to work. Before we go on to looking at loops, what we want to do is just have a quick look at conditional statements slightly further, in particular in the context of this workflow that we're showing on the right hand side, because this is similar to the sort of thing that you'll be using in the second video with DOM. So here we're assuming that we've already run the analyze particles function and that we've got this results table, and we want to determine whether or not we've actually detected anything. So for this we would use the endResults function, which just gives us back, or it returns a value telling us how many rows there are in this table. So assuming everything was set up right before and we hadn't already got the results table open before running analyze particles, we should find in this case that it's, well, based on the scroll bar, probably about 12 or so objects have been detected. And so it'd say, well, 12 is greater than 0, so yeah, we've detected some stuff and we're now going to run whatever code it is, in this case detecting nearest neighbour distances. The other thing that's worth mentioning are all the different conditional operations that we can actually use to check whether or not we should be executing that conditional block of code. So they're just listed out here for your reference. So obviously we've got the equals to. Important to note that this is a double equal sign, because the single equal sign is used for assignment, how we have been previously, assigning a variable. So it's double equals to check for equality, exclamation mark equals to check for an inequality. So as long as, so what we could do previously was say n is not equal to 0, because we know n shouldn't be negative. It would achieve the same thing as just saying n is greater than 0. Also got less than or equal to, greater than or equal to, no surprise there. And then there's a couple of bits here. So you can also test for multiple conditions within the same kind of conditional statement. So here, for example, we're saying if A is greater than 1 and B is less than or equal to 2. Similarly, you can use the line here to say or. So when you've got and, both of these have to be true for this code to execute. Whereas if you've got the double lines, then as long as one of these is true or passes, then this will execute. kind of extension of conditional statements are loops. There's a couple of different flavors of loop. You've got while loops and for loops, and we're going to go through both of them over the next few slides, but we're going to start with while loops. So what a while loop does is it's kind of like an if statement, but rather than just checking that condition once, like is n greater than 0, it checks it, executes the code if it's true, and then goes back. Once it gets to the end of that block of code, it goes back to the top, checks that statement again, sees if it's still true. As soon as it isn't true, then it just stops and executes out of that loop in the same way that the if statement would have just skipped that block of code. One example of this might be if you are automatically detecting an intensity threshold. Say you've got that threshold and it detects it and it says, well, I'm going to use a threshold of 128 intensity units. You run that, you check how many objects you found. You haven't found any objects, so maybe you then drop that threshold by 10%, rerun the object detection, and then test whether or not, again, you've got any objects. And you keep repeating that, and that keeps repeating until the number of objects detected is greater than 0, at which point it would skip on to the next thing. So that would be a kind of feedback loop where it's changing a value until that condition is no longer satisfied. The condition in this case being n is equal to 0. We've got for loops. Similar idea, executing a block of code multiple times. The difference here is that that block of code is executed a fixed number of times. Like you tell it, I want you to execute 5 times. And you also have this additional variable which acts as a counter. So you know when you're in that code whether you're on the first iteration, the second iteration, the third iteration, and so on. So going back to while loops, like I say, the statement here is very similar to what we had with the if. We're just replacing the word if with while. But otherwise, yeah, we've got this. We've got our conditional check here, and then the block of code that we're going to execute in between our curly braces. So the example I've got is generation of a random number, as we saw previously, using that random function. We then check whether or not that's greater than 0.1. If it is, it prints and says, yeah, random number is greater than 0.1. And very important here is that it then reassigns the value here. If we didn't do this reassignment, it's just going to keep checking it against that original number, and there's no way that it's going to, if this was true first time around, if we don't update the value assigned to random number, it's just going to keep on going for infinite, and you're going to have to kill your macro, because yeah, it'll just keep running forever. So let's assume that we've done that, we've updated our random number. After a few iterations, then this is no longer greater than 0.1, so it exits, and then it will tell us that random number is less than 0.1, or actually just say less than or equal to 0.1. So we can have a gander at that using macro 7 that you've downloaded, and yeah, let's see how that goes. So here we've got the macro code for while loops. If we scroll to the bottom, you can see that it's largely the same as what we just saw in the slides, slight few variations. So we're generating this random number, assigning it to a variable random number. We're going to check against the threshold, which in this case is actually being assigned to a variable so that it can be reused here, here, and here without having to hard code it in each. Benefit of the variable. And then we've got this while loop format, so like I say, very similar to what we had with the if. We're just changing while for if, and then checking if that's less than 0.95, continue on, random number is less than this, blah, 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 blah. Important step there, reassigning that random number, and then once it's greater than, printing that the random number that we've currently got is greater than or equal to 0.95. So let's give that a shot, and you can see there that, yep, 0.4426, 0.5419 and 0.1852 are indeed all less than 0.95, whilst 0.981 is greater than or equal to 0.95. We can clear that, just give it one more run, and same again, all good. Having a look now at the other type of loop, these are for loops. As I said before, these work similar to while loops, except for the condition is always specified at the beginning, so it knows how many times it's going to be evaluating that particular loop. As such, the format is slightly more complicated. Rather than just having a single condition within the parenthesis here, we have this three-part kind of control over how the for loop works. So, general format is that we've got the keyword for there, whereas previously we had things like while and if. Now we're typing for. And in the parenthesis, we've got these three elements separated by semicolons. The first one is the starting condition. Second one is the ending condition, or, well, technically the continuation condition. And the third one here is how that count progresses through each step. And the other thing that's useful here is that we have this value. So the kind of progress through all these iterations is controlled by the value of this assigned variable here. Now, convention is that you would assign that the value I or j, but you could call it anything. You could call it my iterator or iterable. You could call it that, but I'm just going to call it I to keep it succinct. So we start off with I is equal to 0. It continues for all the while that I is less than 5. And then on each iteration, it increments that value of I by 1. So that's what this notation here, I++, is equal to what we have written here, which is I is equal to I plus 1. So all it's saying is it's just going to add 1 to that value of I each time. And that will continue until I is no longer less than 5. So what we're going to do, all the code we're going to execute in that is just the print statement. So we're just going to print current iteration and then the number. And you'll see that, again, that starts at 0 and goes 0, 1, 2, 3, 4. When it gets to the end of 4, I will become 5. It's no longer less than 5, so this can't execute anymore, and we just skip out the bottom. Right, our final macro that we're going to look at as a demo, that's number 8, so let's just head over there now. This is macro number 8. Similar sort of thing to what we had last time. Again, slight change here in that I'm using a variable to specify that end iteration there, but it's still 5. So for I is equal to 0 starting, continue while the I value is less than number of iterations, which is 5, and increment by 1 each time, and then print what the current iteration is. So let's run that, and on the right hand side is to go current iteration 0, 1, 2, 3, 4, and then when it gets to 5, it's no longer able to proceed. As I say, this is just a variable name, so we could call it anything. I will go with my classic myvar. You just need to change it anywhere that appears. And then if I clear this, you should see that this literally just runs exactly the same. It doesn't care what that's called. It's just, as I say, for consistency and for tradition, it's often called I or J. Now, just before we finish with if statements, conditional statements, loops, and all of that, I just want to introduce the idea of nesting these. So far we've kind of progressed from having a series of operations which we execute in a linear manner to introducing the idea of conditional statements and loops we've just done. But you can also mix and match these even further. So you could have a conditional statement within a loop. In fact, you'll see this later on. You could, I think it's the second exercise in Dom's worksheet, where you're going to be iterating over a few numbers and then have a conditional statement in there that prints whether or not that value is true or, is odd or even. Another thing that you could do is actually have another loop within a loop. So this whole idea is called nesting, and the reason that you might want to do this, especially in the kind of context of what you'll be doing again later in the worksheet in the second section, will be iterating over multiple objects, trying to measure those nearest neighbor distances. So you'll be saying, right, well, for the first object, I want to compare the distance to all other objects in that particular image. Then you want to move on to the second object, compare all different objects in that, and move on to the third, compare all distances to all other objects, and so on. So in order to do that, you would basically have your first loop, which is iterating over all objects, and then in that case you would have another loop iterating over all the objects again. Of course, they would both be going to the same number. Key things to note here are that you have to use a different variable. You couldn't use I for both of these, otherwise they'll start to conflict. So this is why this inner loop is J. But if we look at this in a very basic format here, what it's going to do is for the first iteration of this, I is going to be 0, and then it's going to run through this whilst I is still 0. So in this case, value A is equal to I and value B is equal to J. So it's going to be while I is 0, 0, 0, 0, J goes through 0, 1, 2. Then once we've finished iterating this 3 times, we're going to go back to the beginning. I then becomes 1. And again, we iterate over this 0, 1, 2, 3, or 0, 1, 2. And that's going to continue on until I is 9, again 0, 1, 2, and then I is going to be 10, so it's going to fail this condition and it's going to pop out the bottom. We can look at this further in the context of that sort of looking at different objects. So here it's slightly different. We don't want to give you all the answers straight away, but basically consider that you've got objects detected in 2 frames of a video, say. For simplicity, we're going to identify 4 objects in the first frame, 4 objects in the second frame, and we've identified these by the ID numbers 1A, 1B, 1C, 1D, so for the 4 in the first frame, and then 2A, 2B, 2C, 2D in the second frame. And what we're going to do here, rather than what you will be doing later on, which is saying, what's the distance between this one and all its neighbours, what's the distance between this one and all its neighbours, we're going to say, what's the distance between this one and all of the objects in the second frame, what's the distance between this and all objects in the second frame, and so on. So if we just overlay those 2 for the sort of sake of schematic simplicity, what we'd do, or one way of looking at it, would be creating this kind of 2D array of point-to-point distances. So this first row here corresponds to the distances for point 1A against point 2A, 2B, 2C and 2D. Similarly, all values in row 2 are going to be for 1B through to 2A, 2C, 2B, 2C, 2D, and so on. And so what we want to do is we would say our outer loop here, so this first one is for I is equal to 0, I less than the number in the first frame, so 4 I plus plus. So what it's going to do is it's going to start with this one, and then this inner loop is going to iterate over all the points in the second frame. So again, that's just going to be 4. So that's going to go, 0, 0, 0, 0 for I, and then 0, 1, 2, 3 for J. Then I is going to go to 1, and then it's going to be 0, 1, 2, 3 for J. So if we have a look at this in action, so for that first one, if we look at this, and then in the grey box, it's just kind of a summary of what's going on. It's not the actual code. So I is equal to 0. That is what's been set there, and J is equal to 0. So we're looking at these first 2 here. So remember, indexing here is starting at 0 rather than 1, just to confuse matters even further. So for the 0 object in frame 1, that's this 1A, against the 0 object in J, which is or in frame 2, which is 2A. Let's say that distance is 7. Then, while still in this first loop, so I is equal to 0, J is now incremented. We've gone through this, we've measured our distance at 7, we've gone up here. J is now 1 because of this. So now we're measuring still the I equals 0 object in the first frame, so still 1A, but J equals 1 is our second object, 2B, and we've measured a distance of 2 there, so yeah, that seems right. If that's 7, that could be 2. Then we're going to increment again, so now I is still 0, but J is 2, so that's our third object, 2C, so that distance there is 6, and then the last distance there is 10, all whilst I is equal to 0. So now, in that first loop there, we've iterated over this 4 times, and this now is no longer less than, so J will be 4, so it's no longer less than the number of objects, it's equal to the number of objects, so we increment our I, so if you look at that, I now is equal to 1, but J, because we're starting this again within this loop, J is equal to 0, so now we move on to our second object in frame 1, but we go back to comparing our J equals 0, so our first object in frame 2. And I'll just let that run automatically now, so you can see this iterating. So all while I is equal to 1, it goes 0, 1, 2, 3, same with I2, and then finally we go I3, so that'll be the last round, 0, 1, 2, 3, and then it's finished. We've populated our entire row, we've populated our entire 2D array, and we've measured all possible combinations of all points in the first frame to all points in the second frame. And just to end on a slightly simpler note, we've also got batch processing capability. So at this point now, you've hopefully got all the components that you need to create your macro. So everything from using variables and numbers, arrays, and string text, being able to combine those mathematical operations using concatenation, to doing more complex sort of optional things and loops, so conditional statements, while loops, for loops, and so on. So now say, yeah, okay, that works for a particular image. Now we want to use a second image. Well, the way you could do that is by using the batch processor. So this is in ImageJ, it's process, macro, batch process. And you could put in, you specify here your input folder. So this is just a folder containing a load of images that you want to process. Then you'd specify an output folder. So what the output folder will do, it will save the active image once that macro is run. So every time that macro finishes running, one of your images, assuming you've got images open, will be the last one that was used. So like the kind of active image still within ImageJ. That one gets saved to that folder. You can tell it what format you want it to save in. The default, of course, is TIFF. And then you just put in your macro code either here, just copy and paste from your script editor, or you can click open and load in a pre-saved macro file. So macro files with the extension .ijm. And assuming that's all good, you can click process, and it will just very quickly, generally, run through all of those folders, files in the input folder and save them to the output folder. Things to note, you can put in file filters there, so you could ignore everything that has a particular name if you don't want to. If you only want to load, for example, images which have C1, maybe you're just wanting to load the first channel and all your input images have been separated into individual channels. You could say, oh, well, only analyze anything that's got C1 in the name. And also, you've just got to be aware of maybe not using GUI elements. If you've got any of these dialog boxes that pop up, that could cause problems, because if you've got 1,000 images, you don't want to keep popping up and saying, yes, I want to filter with median and a radius of 2. If you do have those options, you're better off hard coding them at the beginning, just explicitly defining the variables. Okay, so that's the end of this session. Thanks for making it this far. I hope you found it useful and interesting. Please do check out the second part. There's a link to that in the description below, and as long as I've got my YouTubing done correctly, there should be a box pop up on the screen as well right now. And also we've got loads of other material on our GitHub, obviously more videos on our YouTube, and there's just general facility information on the right link there. Please like and subscribe if you enjoyed this video, and yeah, cheers.